Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Daiman and my number matric is CE220106. And today I will present our group, which is group 3, about principal controller. So I will represent for the open loop system, which is PID controller. So this is block diagram of PID controller with open loop. So okay. This is the simulation of block diagram PID controller for open loop system. So this is block parameter, which is step time is 1, initial value is 0, final value is 1, and sample time is 0. Okay, and then it connect to the block parameter sum, which is list of sign is plus minus, and then it connect to the PID. So the PID, the proportional gain is 0.6, integral is 0.72, and derivative is 0.18, and filter coefficient is 100. So the capacitor formula is P plus I 1 over S plus D n over 1 plus n 1 over S. And then it connect to the transfer function, and the numerator coefficient is 16. Denominator coefficient is 1 to 4, and then like this, s over 2 plus 2s plus 4 for the transfer function. And then the last block is scope, to gain the data output. So I will run this simulation. Okay, I will open the scope. This is PID controller output. So we can see data from PID controller. Alright, that's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Izatun Nazira binti Ashari and my matric number is CE220122. Okay, my part is I will explain about the open loop system with gain. As you can see, this is the block diagram of a loop system with gain, and we have a output graph for open loop system with gain. So what is the open loop system? Open loop system is a type of control system in which the output of the system depends on the input, but the input or the controller is independent of the output of the system. This system do not contain any feedback loop and thus are also known as non-feedback system. Okay, what is the open loop with gain? What is the open loop with gain? The open loop with gain is defined as the change in output voltage divided by the change in the input offset voltage. The transfer function gain is a parameter that connects the steady state conditions and stability with the transfer function. It is the ratio of what you receive from the system as output to what you input to the system under steady state condition. Okay, let's define the transfer function gain with an example in real life. Consider kicking a ball with your palm and bouncing it back and forth. The height to which the ball bounces up and the hand kick we apply share a certain relation. Mathematically, the relation can be defined as the ratio of height to which the ball bounces to the force of the kick given and symbolize the transfer function gain at the steady state condition. And lastly, every control system designer aims for a stable system, since stability is an important factor for a system to behave as expected. For high efficiency and cost effectiveness in some scenarios, we need to pull the system operation up to saturation regions or non-linearities. In such system, the relative stability is a significant parameter. The relative stability is the measure of how close the system is to instability. It is usually defined using gain margin and phase margin. And if you know the transfer function having a gain in the system, calculating the gain margin is an easy way to check for relative stability. I will pass to the next presenter. Thank you.
Hi, my name is Sayasati Arumugam. My matric number CE220114. I would like to present on P control in closed loop system. This is the circuit we have designed, which is connected with step, which helps to release graph in scope, Second, which is connected to sum, which is plus minus, and also connected to the scope and also to the circuit. It is connected to PS, which we have used PID controller, and we have set up as PS. After that, it is connected to the equation of my group, which is 16 over s squared plus 2s plus 4. And it is also overall, it has connected to scope, which helps to show the output of this circuit. I would like to show the scope. This is the output that we have gotten for this equation. Next, I would like to explain on how to get the reference plotting. First, we have to press on PS controller. Then we have to set as transfer function base and tune it. After pressing tune it, first we have to apply it and press OK. After press OK, press again on the PS and press tune it. After pressing it, we will get a graph as shown here, which has block response and also tune response. By replaying on the response given, the graph will be changing as different a bit. As also, if we change the domain as frequency and time, the graph do change a little also. So this is for P control. Thank you.
Assalamualaikum. My name is Nur Syahda binti Nur Aslan. My number entry is CE220137. Today I would like to present about the P controller with closed loop. So this is our block diagram. So first we need to use step function and connect to the scope. This scope will show the output. Okay. So next we connect the step to the sum parameter, which is plus minus, and connect to the PI controller. We also use the PID controller, but we need to set at the control at this PI control, and then we need to set proportional to 0.45 and integral 1.2, apply and OK. Okay, then for PI control, we connect to transfer function. This is our equation, which is 16 over s power of 2 plus 2s plus 4. Then for the transfer function, we connect to the scope. Okay, so we need to run the diagram and click to the scope. So this is the final output for the equations. Then so continue to the reference float. So we need to click the PID controller and set up at the tune and apply. Okay, and the output will show this diagram, which is this is for block response and this response. Then we need to update block. So this is the final output for reference tracking. So that's all from me for the PI controller part. Thank you. Okay, so let's continue to the PID controller with the closed loop. So we still use the same block diagram. So first we need to use the step functions and connect to the sums, which is plus minus, and then connect to the PID. So still use the PID controller, but don't need to change the controller because this is a PID functions, but need to set up at the proportional 0.6, integrate 0.72, and then derivate is 0.18, and apply and also OK. So after that, we connect to the transfer function, which is the equation 16 over s power of 2 plus 2s plus 4, and for the step function, we need to connect to the scope, and also for the sum and connect to the scope. So scope will show the output. Then we need to run the diagram. And click the scope. So this is the output for the transfer functions. Okay. So next, we need to click the PID controller and tune the graph. For the reference plot, which is you need to click the tune and apply, and also OK. So they will show the output will show like we show this PID tune. Okay. This is the reference tracking before we run the update block. So next, we need to write. So this is the final reference tracking is tunes response. So that's all from me for PI and PID controller. Thank you.